The Celtic Engineer is a weekly newsletter produced by Celtic Engineering Solutions. We hope you enjoy it. Active versus passive. Unless you have noise, you may not even think about filters, let alone whether you should use an active filter or a passive one. Let's start out with a definition. What is the main difference between the two types of filters? Simply, an active filter uses an active component, one that is connected to a power supply. A passive filter only uses the power that is supplied by the signal it is filtering. One other difference is that active filters never use inductors. An active component is most often an op-amp, but it could just as easily be a transistor. A second difference is the output impedance. The output impedance of the active filter is low because the op-amp is driving the output. Not only is the output impedance low in an active filter, but the op-amp acts like a buffer, decoupling the inputs and outputs. For example, both circuits will work similarly if a high impedance load is connected to Vout. But if a low impedance load is connected, the circuitry connected to the Vin side of the passive filter will be affected by the increased load placed on the circuit. As for cost and complexity, the passive filter wins hands down in many situations. If you can get away with using a passive filter, you should. But if you need the advantages provided by the active filter, the additional cost and added space is well worth it. There are three situations where a passive filter shines. The first is when the signal you are filtering is a power circuit. That is, you actually provide power from a circuit, but it is noisy and needs to be conditioned. Removing ripple from a DC signal is a good example of this type of circuit. The second is when you need a simple circuit with just a little bit of filtering. A simple RC will give 20 dB decade of noise reduction. This is part of the KISS principle, keep it simple, stupid. Don't make things needlessly complex or costly. The third situation where you would want to use passives is for high frequencies. That is when f10 millihertz. You want to use an op-amp capable of frequencies about 100 times higher than the frequency you are filtering. So if you have a frequency of 10 millihertz, that means you need a 1 gigahertz op-amp. The choices are few, and the cost is high. This is a situation when you will be best served by passive components. The active filter has more components, requires a connection to a power source, and usually costs more. That may sound like it is a bad choice, but it has some amazing properties that make life better. As stated above, you can control the gain of an active filter, set it where you like, for the most part. Another great attribute of an active filter was mentioned above. It isolates the input and output signals. In low-frequency cases, inductors tend to be large and costly. An active filter, which does not use inductors, can filter a signal for less money and using a smaller footprint. In fact, in some cases, the active filter can be miniaturized where the passive will never be anything but large and heavy. It should be mentioned that it is usually easier to design and tune an active filter than a passiver one. An active filter uses an active element such as an op-amp or a transistor. Recently, a new active element has come on the stage, the switched capacitor. While switched caps have been around for a long time, having switched capacitors available in monolithic form is new. The typical accuracy of the cutoff frequency of a switched cap filter is plus 0.2%, set by an external clock frequency. They are able to change the cutoff frequency over a wide range simply by changing the clock frequency. They also have a low sensitivity to changes in temperature. The ability to change the tuned frequency on the fly is a big game changer. You may not need this capability for every circuit you make, but for the times you do, switched capacitor filter S are the bee's knees. We hope you've enjoyed this Celtic Engineering Solutions moment. I'm Sean O'Leary, PE, licensed electrical engineer. This podcast is sponsored by Celtic Engineering Solutions, LLC, a design engineering firm based out of Murray, Utah, which can be found on the web at CelticEngineeringSolutions.com.